Hey guys.
Yeah.
I was just working on my Airhead yesterday, wiring in this little Android Auto or CarPlay screen, which is finished. It's hooked up into the headlight bucket here, into the connector board, where I actually measured amperage draw and all that stuff to make sure we're not overloading anything here on the bike. But then I realized my instrument cluster here, the two instruments, the speedometer and the tachometer, they both work, but they are kind of like shaky needle and all that. This one here is a 74, so both instruments are still mechanically driven with, speedometer cable and tachometer cable. And I had been thinking of taking those out of the housing. I do a little bit of watch repair on the side as a hobby. And I was thinking, if this is all mechanical driven, this is more or less kind of like a watch movement. There are little gears in there, there are moving parts. And I wonder if we can maybe take those two instruments apart, get the little gears out, clean them off, and put it all back together, put some lubricant on there, and hopefully it works a little better. I don't know if I'm going to make things worse, but they will need a rebuild anyways at some point in time. So we're just going to yank them out of here. Really simply held in place with three bolts here in the front, right between the handlebar and the plastic housing. There are three bolts. And then you have your speedometer and your tachometer cable going in the bottom. And then in the center is a big plug. We're going to try to take this all out now. So there are the three bolts that you have to take out, and then this housing will slide upwards. Then here is the speedometer cable, which goes to the transmission, and here is the tachometer cable, which goes right down here in front of your left side cylinder. And then in the center, there is a Phillips head screw that holds an electrical plug in place. So that's what needs to be taken out. And then you can take this entire housing off. So here we go. I hope you guys can see most of what I'm doing. So I'm gonna try to reach in here and undo. Oh, that's tight. Okay, maybe not. So the knurled nut down here is supposed to be only tightened by hand. But this one here seems to be so tight that I can't get it off by hand. I'm just going to grab it gently with a pair of pliers without making any big marks on it and turn it. Oh my goodness, still very tight. What I also just noticed is I'm also spinning the housing of this cable, which is not good. That is not good. So I wonder if I can maybe hold on to the jacket and then twist the knurled knob here. Oh, I see. We're actually turning the threading in the instrument, and that's not good at all. So we're definitely not taking anything loose. Let me see if I can get the other one off here. Oh yeah, this one is no problem. So the tachometer cable, no problem. Okay, we got it. All right, it was just stuck, so remember to always put a little grease on there on the thread, or come on now, come out of there. I hope I didn't damage anything. Okay, so we got it loose. That's promising. So I have the tachometer cable loose. You just pull that down a little bit, and then the cable comes out of the instrument. And the same over here on the other side. And just pull it down a little bit. Yeah, not bad. And then I had a 10mm wrench here. I'm gonna, of course, my new screen here that we just installed is a little in the way now. Swing that out of the way. You don't need to take the bolts out, you just loosen them up. Then you can wiggle this whole thing upwards. As you can see, it's already coming up. We just need to get that one Phillips head out so I can unplug the whole thing from the bottom. Here, I'll show you before I pull it out. Here's Phillips head. Let's see if we can get to that. If I could turn it sideways a little bit, that would help. I guess I didn't leave myself a lot of wiring harness length here. Nope, we're not gonna make that. Smaller bit. It's already loose. It's just a little sheet metal screw. So let me show you real quick. Here's that rubber plug. This whole big old rubber piece needs to come out, and that silver part is a finish washer that's still stuck to the plastic. So I'm just gonna try to get the plug loosened up. There we go. What else do we have here? So this is what I was talking about. Here's a big old connector panel, and this is the plug. Lots of little pins. It's always a good idea to clean those off before you put them back in there. Maybe put some deoxit on it. And now we're going to take this whole contraption, put it on my desk and disassemble it. And what was turning earlier was this whole threaded portion here. So the knurled nut was on there, and this was spinning with the nut. And that's of course not desired. But yeah, let's take this upstairs and start working on it. What I just mentioned is this stuff removes oxidation, improves connection, seals, and protects surfaces. If you get a little can of this, it's pretty expensive, but you can just put a little spritz on each of those contacts. And then while you do the rest, it can clean up the oxidation and, you know, make sure when you put it back together you have a good connection. All right, guys, so let's see what we can come up with here. Don't really need many tools here. This is a #1 Phillips. This plastic cover here on the outside, as you can see, it has some screws here. There's one, and there's one. Has already been repaired once with epoxy, because these plastic parts, unfortunately, they get pretty brittle over the ages. And we'll see if we have to do more repair here. So like a piece broke out of this housing here on this side. When I got this bike, it was all in pieces. Luckily, the instruments were still working. But the housing here, this corner, as you can see, the screw's kind of stuck in there actually. So we don't need that. Let's put that out of the way. This is really just a dust or water protection. The glue is coming out. We'll see. Now we're gonna be digging in a little more. Bunch of little screws. These here, they hold the instrument to the center section, I think. Let's see if we get it out without taking those out. The screws here are also not original anymore. Some were missing. So I just switched to manual focus so it doesn't keep changing focus when my hand gets in the way, which probably helps you guys. Oh yeah, this is all pretty crunchy, all this plastic. You can buy the instrument cluster housing. I think it's made by Rock, but be prepared to pay up. It's expensive. I don't remember. I've had it open. I've replaced some stuff in here, but it's not fresh in my memory how this all comes apart. I also put some new, there's some seals, some foam seals that go in here. All right, I see how it goes. Flathead screwdriver. Flathead screwdriver. Get it out of the way. Here we go. So yeah, I guess this needs to come out first. See there where those pin goes through. And then this circuit board in here, this is not stock. This is made by KATDASH. What's called a KATDASH replaces all the incandescent light bulbs with LEDs. So I'm going to try to install new threaded inserts. So here on the edge of the housing, you see lots of cracking. There's still a brass insert. Here's a brass insert. But in some places, those brass inserts had broken out of the plastic. And so I couldn't use machine screws anymore. And that's when I started filling those in with epoxy and use pretty much sheet metal screws for it to cut into that plastic. But I have thread inserts that we might be able to glue in place. All right, let's take the KATDASH out. Okay, let's see. Oh, here we go. So KATDASH, this entire unit here, you get when you buy that as a replacement for your instrument cluster to replace incandescent light bulbs with LED. So this seems to be working really well. So far, so good. It's not cheap either, but I think it's a worthwhile upgrade. So this side is the tachometer, and this is the speedometer. This is the puppy where we had the thread spinning here. This is all brass down here, so you guys can see. Let's see. Let's take, is there another bolt here? No. Oh yeah, it was just stuck a little bit. So be gentle, be careful. This comes out with, yeah, here we go. You don't want to break off the instrument needle, accidentally. See all this mess here? This is glued together, and yeah, not very happy about that. So let's put this out of harm's way here real quick. And then yeah, the gasket needs to come out of the way before I do any kind of potential repair to those broken and cracked plastic pieces here. I don't even know what type of plastic this is. And that's why my gluing technique here with epoxy and all kinds of different things isn't really holding up either. So now I probably started a bigger project than I wanted to. But we're going to take this gasket out of the way if we can, because I would like to, this is relatively new. I had already once replaced this. Yeah, here we go. Gasket. All right, most of the thread inserts are still there. There. This is bad and this is bad. I wonder what we're going to do. So these are for 3D printing. These are heat thread inserts. And I think I have the correct size for those little machine screws. No, that's not it. And I wonder if we could, oh yeah, these fit. I wonder if we could install those into this beat up broken plastic. And the setting by heat is going to melt it all back together. And then I would have to first drill this out, because those thread inserts, as you can clearly see, they are massive compared to the thin little thingies that were in this plastic here before. So I would have to drill this out a little bit. So let's put this aside for now. We're far away from that. And let's take a look at the instrument here. Why was this spinning? It's really not so great. Look at all this messy, old grease, sticky, like you don't want to touch your the face or your needle. The needle looks like it would probably also break off in a heartbeat. So I just looked around to see what we potentially have. This is not bad. Better than holding it the entire time. I'm going to try to remove the needle or the hand, as it is called in watchmaking circles. And since I'm going to be reaching for the front of the instrument, and I don't want to necessarily leave greasy fingerprints on there, I'm going to put on some finger cots. Finger cots? They're kind of like a rubber glove, but not. Looks funny, but it does the trick. So I'm going to try to take that off. I have a little thing called a dial protector. It's for watches, but I don't see a reason why this wouldn't work on an instrument like this. Slide it on the dial to protect the dial, and then we can see what kind of levers we have here. These are hand removal levers for a watch. I wonder if they have enough reach. Oh, on one side it's grabbing something. Nope, it's not. Yep, that's not doing it. Let's see, the bigger version. Oh, here we go. All right, and now we're going to put this far, far away. So we're not breaking this. Oop. Little watch part container. And dial protector not needed. Now we're going to try to take the dial off. Someone has been in here before. The screws are definitely not virgin quality anymore. Okay. And then we can take this whole thing and also put it in a little watch part container here, together with the hand. Put that out of the way, like that. Looks pretty complicated, but I don't think it really is all that complicated. Just have never taken one apart. We'll see what we can come up with. Ultimately, it's just important to take the moving parts apart and lubricate it so that friction is removed. Yeah, this looks really ugly, gnarly. So I'm going to try to... Nope, doesn't fit. Let's see what else we can come up with. Oh, things are coming apart. All right. So this is the drive that comes from the cable, right? There is grease on there. and I see a little circlip. So I wonder if we remove this little, oh, there's rust on there too. Oof. Oofta. And then down yonder, you see a little plastic that's a bearing of some sort of description. So what else can we see here? There's another circlip, and then you can pull that gear off. So the whole drive, now I have grease on the finger cut, so that was pointless. That was totally pointless. But yeah, at least you don't want to get any fingerprints on your instrument dial. That would be really bad. So the whole drive, I think it's using a magnetic field, so it's spinning one direction, right? Yeah, always just one direction because we're always just moving forward, right? And in there is a magnetic pickup that makes the needle move. But as soon as the movement here stops, the needle gets, by use of this little clock spring there, gets moved back to its starting point. So I think if we get this cleaned up here, we might have to just remove those little gears and pull this whole drive shaft out and then clean it all off and then put ever so slightly a little bit of lubricant, like watch lubricant, which is very lightweight oil on there. Let's do a little bit of some cleaning here. So this is, like I said, this is the speedometer / odometer. The odometer parts here, the gearing, all that could also be cleaned off a little bit, and then a little bit of some watch grease on there. But I'm a little hesitant to yank this all apart because this is rather crude. If I screw up with any of those parts and damage something, we might not be able to put this all back together. See here, it's adjustable. So you can angle adjust this little this pinion drive here, or warm gear drive, I should say. This is a warm gear. And over here, how is this? Oh yeah, there is gearing between those two. So between the trip meter and the odometer. Yeah, that's great. And then this here is for the knob to reset it back to 0 when you're at the gas station. See that? So I don't think I'm super worried about the odometer part. I'm just worried about the dirtiness of the actual drive here. And we are going to, I just want to make sure I don't grab any of the plastic parts here. Okay, let me grab some more tools. I am wondering if there is any kind of way to get the bottom, oh yeah, there are 3 little screws, the bottom away from the top without messing with this upper mechanism here. I think we should try that. Let's try that. That doesn't fit. Oh yeah. You just gotta move slow. So this whole side piece here, this little drive in this gear, and then this warm drive up here can literally stay in place, I think. Yeah. So this is what I was talking about. Oh, there is so much. Oh, the screws. That's fun. There is grime and dust and particles. This is a magnet, or multiple magnets, I would say. And as the speedometer drive spins, it grabs this disc up here and moves the needle, following the magnetic field, so to speak. And when the magnetic field stops spinning, then the needle goes back to its starting point. So the needle would go this way, and then it spins back. So we're not going to mess with this at all. We're just going to try to gently clean this off. This is connected, this tiny little shaft here where the needle sits is connected to all this, and I don't want to screw this up. But there is definitely lots of schmoo little metal particles. And this is all here magnetic. My screwdriver is very attracted to it, but it's very dirty. And so I wonder if just pure cleaning off of debris would actually do anything. So let's grab some, let's move some stuff out of the way. Let's grab some rubbing alcohol. Oh, there's like a big old metal piece. Oh, I just dropped it. All right, so let's see. I found snap ring pliers that are a little closer, and we might be able to get this little snap ring off of the end of that gear without snapping it in half. Oh, there you go. Okay. And then we should be able to pull the gear off. At least I think we should be. There's actually a flat spot on that shaft. So I wonder if we have to use some sort of puller to get that off. Oh, you know what? I see what's going on here. Let's take this out. I know this is something that I should probably not mess with, but I'm doing it anyways. If I'm going to be on eBay tomorrow buying a new instrument. Oh, here we go. So this can be easily cleaned up. And there is this part. Yeah, this can also be easily cleaned up. So now we just need to get this gear off, and I bet you there is another snap ring in there, and then this whole thing can come out. And then I can wash this entire thing out and then assemble it with just a little bit of grease, you know? Not like tons of stuff. I mean, tons of stuff. So what are we gonna do? I think I found a solution how to remove this little gear off the shaft. I just put my screwdriver in between here and twisted it, and that was already enough force to move the gear slightly. So I didn't expect it to be too stuck because it has a flat spot side and it's held on with a little clip, right? So there's not necessarily any kind of press fit here. Now I have moved it a little bit, but I'm running out of leverage here with my screwdriver. Oh, there's also hair in here. That's great too. That definitely doesn't help the situation with the driving of a speedometer. I guess I need to get a bigger screwdriver. Just don't break the gear. And then how are we going to get it back on? is the next question. There you go. All right, and then what's in there now? Okay, there's one side where the flat end is a little recessed. That's the one that needs to go against the shoulder here. And now I need to see if there's another circlip in there. I don't know. How do you get this apart? I think we're going to not take this apart any further, but rather just clean it, wash it, dry it, and reassemble. Yeah, so we were looking at getting this all disassembled. Got this little warm drive gear off, and the rest of it is still here in plastic. We're going to get to this in a second. But yeah, I was looking at the inside here to see if there's maybe another snap ring or some other thing holding things in place. I've also noticed that my audio recording is way too loud, so I just turned that down a little bit for you. So, and then I just, by sheer coincidence, I just pushed upwards on this little shaft, and this is what happened. The little ring, metal ring on the outside, magnet on the inside, the entire shaft, and then this little nylon part here, which just locates everything, came out very easily. And that allows me now to really clean this off with rubbing alcohol. Then I also, let's push this over to the side. Let's put this over here. I was kind of looking at the crack here in this nylon piece. Let's zoom in a little bit for you guys. And let's focus on this for you guys. So here we go. That little cracked piece. I will most likely use some super glue, liquidy super glue with, I have polymer powder, so I can build up the outside a little bit to strengthen this. So I think the main reason why a speedometer starts having the wobbly needle is if there is metal debris on the magnet or any kind of friction in those bearing surfaces. And I'm assuming that the bearing surface in here, I wasn't able to take this apart any further, and I don't want to. This is just a friction fit. Maybe there's a bushing in here. That just needs some lubrication. So then I started doing some research on what kind of lubricant we're going to be using. Standard use for nylon gears, as far as I could research, is white lithium grease, which is a petroleum product, which is not really good for plastic parts, but apparently white lithium is fine. But what I'm going to be using is this stuff, which is super lube. Super lube is a multi-purpose synthetic grease. Super lube is silicone based, contains PTFE, which is a very slick material, has temperature rating from negative 45 degrees Fahrenheit to 450 degrees Fahrenheit. So within this temperature range, it will maintain its lubricity and will stay in place and not run off. And then another big advantage of this stuff is it's synthetic, which kind of means that it will maintain its properties for a very long time. Whereas white lithium grease, petroleum-based, it can actually harden. So some of the grease gets, pasty, not pasty, kind of like waxy after a while, and then harden. And also the oily substances in that white lithium grease can separate and then run all over the place, so smear other parts where you really don't want the lubricant. So I'm thinking that I'm going to be using the super lube. It's fairly inexpensive. You can buy it on Amazon. I'll put a link down below. So let's keep going. We have this now all completely apart, and now it's really up to me to just use some rubbing alcohol. I'm looking at this here, if I can separate this, but I am not super convinced that I can just push this out. I'm not sure. And I don't want to break this nylon part. So I think there's enough access to the axle here and to the gears that I can degrease this and get fresh lubricant in place. And we're going to be using a lubricant very sparingly. I don't want the schmoo all over the place. So now I was looking at getting this part of the gear drive out. So this whole brass part, separating that from plastic. By the way, here's the little knob that you use to return your trip meter to 0, and it turns. It's very resistant to turning. So as you can see, there is an E-clip on here. That's the name of this type of snap ring. And those E-clips, they come off relatively easily. So let's put some stuff out of the way. Here we go. And make sure we have this focused for you. There you go. So the E-clip, you only need to put a little screwdriver in there. And then that comes out of its, maybe a little larger screwdriver. Here we go. And then make sure you don't lose it. Oop. So that comes off. So now we have this clip and that E-clip. And then we should be able to pull this out. And oh my goodness, yeah, there is a little bit of schmear on here. This feels like an O-ring here in the middle. There is an O-ring in there, which is good, but the lubricant has completely hardened. So I think if I clean this up, this is a plastic part, so be careful not to break it. If I clean this off and put a little bit of our super lube in there, this knob is going to turn much easier than before. It was really stiff. Every time at the gas station, I had a hard time setting this to 0. So we have that out. And now let's take a look here. The bearing, this little bearing down here, we're going to leave in place. I can reach in there with a Q-tip and clean it out, I think. I would like to take this all out. And I've looked at what's potentially holding this in place. And there seems to be a little set screw. And we're just going to shove a flathead screwdriver in there. Make sure you don't strip it. You only really have one. Oh, this doesn't fit very well. Let's see. Oh, yeah, here we go. Set screw. And we probably don't even need to take it completely out. We just need to. Oh, here we go. So now this is all already turning freely. And we can pull it out. So now we have the drive. This is probably a 2-piece. Here, the inside is where your speedometer cable goes, and that's spinning the gear. Here's another circlip which we're going to take off. This looks like exactly the same size. We're going to go in here and and the end here seems to be pretty rusty crusty. This is rust. Yeah. I'm not sure if I'm going to be able to pull this gear off. Let me see if I can remove some of the crustiness. Wow. It's the same deal. This gear looks almost identical. It is identical. I mean, they have to mesh with each other. So I would say they're probably even interchangeable, but we're going to try not to mix this up. So if I get this gear off, this way, we can probably pull this entire piece out, lubricate the inside, get this all cleaned up, and then put it back together. So for when it comes to the speedometer here, we're almost at the point where we can start just cleaning. This is for gun cleaning. So this is just brass. Let's see. Let's see if I can clean off some of the rust here without damaging this nylon gear. Oh, it's sliding. Nothing broken yet. Sounded bad, but nothing broken. So I'm going to try to just lever this off this shaft. I know this is probably much farther than most everyone else wants to go with this, because it's a 1947 speedometer. And if I break this, you know, eBay purchase, get another old one that's probably worse than this. But I really want this to function smoothly. And we're just wedging this off here, levering this off. We still have quite a ways to go. But that's why I had multiple sizes of screwdrivers here. Let's see. Sound effect. Come on. We're almost there. What are we going to do now? Still needs to go quite a ways. What did I do with the other one? How did I manage? Oh yeah, here we go. Maybe that way? Yeah. Okay, without any damage. So here again, I don't know if you guys can see that. Where's my pointer? My little pointer. Here we go. There is a little step from this surface to where that flat side starts. Let's zoom in a little bit. Make sure it's all zoomy. There you go. So there is a little step, and that goes towards the inside, towards this end here. Okay. So now we have that off. Now we should be able to. Oh, here we go. Oh yeah. Look at that. So now we have it all apart. So this is steel. The end here is brass. That's probably pressed on. We're not going to mess with that. But now I can clean the inside, clean the shaft here, and re-lubricate it and shove it all back together. Then we can also take a quick gander at just if there's any wear. But I don't see it. I mean, there's no torque really transmitted here in those parts. And you remember when we were trying to take the speedometer cable off, I had to reach up here and clamp on this brass piece. As you can see, I damaged it ever so slightly, but shouldn't be a big deal. This is brass, relatively soft. I will also probably put some anti-seize on here for the reassembly so that the speedometer cable doesn't get... Oh, I just found this. So I'm assuming that goes in between there. That's good that I caught this. All right, we're just going to clean this off. And I'm going to stop talking and start working. I probably will speed this up for you guys a little bit. All right, guys, so I think I have most everything relatively clean. I'm going to put the smaller metal pieces, at least, the little screws and the circlips here and all that, into my ultrasonic cleaner just for a quick wash. What I'm using in my ultrasonic cleaner is just water and dish soap. I'm not going to put plastic parts in there because, you know, ultrasonic cavitation, so to speak, that causes the cleaning action might mess with the brittle plastic, and I definitely don't want to ruin this. So here, this is a little basket that I use for watch parts, and let's see if we can put all the... I verified those circlips are the same size, so they're interchangeable. Here's a little washer. And then a couple screws. That's my little ultrasonic cleaner, really simple. Set the temperature to around 40 degrees. The water that I just put in is already warm from the tap, warm water. And then we're going to put all our bits and pieces in here. It's just Dawn dish soap and warm water. And then now I have soap on my hand, but I think we're going to survive 5 minutes. That should be fine. Watch your ears. Right. All right, guys. So while you guys were not looking, I took the pieces out of the ultrasonic cleaner, rinsed them off with just warm tap water to get the soap residue off. And then I went down to my shop and just blew them off with compressed air, which is still not a perfect way of removing all the moisture, but I'm going to show you something. So if you have 91 or 99% isopropyl alcohol, which is as close to 100% alcohol as you can, if I can get this open, as you can get, that stuff can be diluted with water. So what I'm saying is, it mixes with water, and as it is being diluted by water and absorbs the water into the 91% isopropyl alcohol, which I'm filling into this little container here, it pretty much takes the moisture off of parts. So now we can just take a pair of tweezers and just dip each part into it. And now the isopropyl alcohol is going to evaporate. The water that was on the part is now in the isopropyl alcohol, heavily diluting, or not, the water is being heavily diluted, not the other way around. A couple of drops of, you can just drop that in there. The isopropyl alcohol absorbs the moisture. And I don't know if this is going to fit. Is it? No. Maybe sideways. Just dip it in once. So here's the grease. And I think that's as much as we will need. So let's start with this and this and this and one of those, and this is still a little rough looking, but hey, it is what it is, right? So this is how that will go in there with a washer in between. Here's a little puffer. If you don't have an air compressor, I use that for watch repair and for camera lenses and that kind of stuff. That fits, no problems. Okay, let's get going. I think that's fine. All right, number one's done. So now we're going to put, I took note of how this metal ring was in here. See, there are two little indentations and a gap, right? This is an open ring, right? And it was in here. If you look at this part, one of the little indentations was here, one was here, and the gap was here. It's literally held in place by this plastic piece here. So I don't even know we're going to get much grease in there. But this all goes back together. That's the challenge here. 3 holes. So I bet they made it so that it only fits in one orientation. At least that would be a really good idea. 3 holes. I have no idea. Let's think. Let's think. Here's this thing, and that has something to do with that over there. Like that. And now we need the 3 longer screws. And that goes... Oh, why is it floating like this? Is it because of the magnetism or because I didn't assemble it? Oh, I see. So another thing that I just discovered, that little nub in there is pretty much the pivot point for this whole contraption, or it goes into the center of our magnet there. So I wonder if I should maybe put a ever so slight amount of grease on that tip. And then we need to manage to line that tip up with a hole here. Let's see if we can accomplish this. There. So you just wiggle it around a little bit. And then let's get one screw started here. Oh my goodness. I have the shakes, man. I have the jitters. Where did my other screwdriver go that I had here? Okay. And let's put the other 2 in here. Ay. Shaky. Ooh. Okay. So now let's think about this briefly. So if you look at the spring really closely, if I turn my gear at the bottom, you see that brass piece moving. Yeah, let's zoom in on it. There. There. So I'm spinning my gear at the bottom, and that little brass piece wants to move just like the needle would. So I would say that is pretty good. There you go. So don't drop it, Heiko. Don't drop it. Let's see if we can maybe support it with this. No, I don't want to. But maybe better than holding it stationary the entire time. Tight. I found my screwdriver. So I have a bunch of those. These are made by Felo, Germany, all different sizes. And the wooden handle, they are originally lacquered like this. And the more worn they are, the grippier they become. So even when you're working on something super greasy, they will give you traction. Okay. Let's not break anything now. Yeah, that's tight. That's tight. And the screwdriver fits the slot really well. Click. 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 Okay. And I'm also going to check if the other screws here are all still tight. Oh, yeah, they could use a little. So what I have here, this is really not so much a super glue, but more like a super glue based filler that you can use for if you have fancy instruments like a piano, for example, and it has a chip in the clear coat. You can use this. It's a little bit flexible as well, so it will not crack that easily again. But it is super glue based. Now we're going to take my air puffer here. Okay. So now I have this in thick and in thin, and then I have a this is kind of an accelerator. So when you spray that on, it's literally going to dry off instantaneously. And this other little bottle here is polymer powder. It's black, doesn't matter. It stiffens up a repair that you make with super glue. So I'm going to try to get this on here, but not everywhere. I just want this to fill in the crack like this. See that? Oh my goodness, now I have it everywhere. But it's no big deal. And now we're going to put a little bit of that powder right on where that seam is. And then we're going to put another drop on top of that. All right. And then we can take, I'm going to do this off my desk real quick. Just spray it on and it cures instantly. So now we have the crack filled with super glue. A little bit of this polymer powder is kind of like a thickener. Kind of like when a bone in your body breaks, your body also builds up on the outside of the break. This is pretty much what we did. It's not pretty, but it'll do it. It'll do the job and hold parts together a little better. And since this is a flexible type of super glue, I'm pretty confident it will not break again immediately. So now I'm going to clean up my desk here with, again, rubbing alcohol. Yeah, that's hard. So this hardens really fast once you spray the activator on. Some of the stuff ran down here. No big deal, right? This is fine, I think. And now we're going to figure out how this goes on here. I'm pretty sure it goes that way. Oh, I have super glue on my fingers, though. I wonder how that happened. Yeah, don't get your fingers stuck together with super glue. It's kind of annoying. Okay. There might have been a drop down here that wasn't hit with the activator, but now it's all dry. Okay. Let's see quick. Oh yeah, like this. Okay, like that. So we're gonna prep this end, put some grease on there, like that. I already put some on that metal gear up here. Yeah, like that. So, and then we're gonna do some on this warm drive gear here, like that. Oh, we're running out of grease. We're running low. And this is only the first instrument. So this is speedometer. And now we're going to put some grease on this. And then I also feel like you see the shaft going through the plastic here. It's open. So I'm just going to rub some on and then spin it a little bit, rub on a little more, spin a little bit. Yeah, I think that's really all we need to do. And now we're going to drop this in place. Yikes. So this is supposed to line up with two gears, with that one and that one. If we can somehow manage to jiggle this all in place. Ha! So now our little buildup of material right there is in the way. So my good idea wasn't, oh yeah, look at that. We can actually do that and stick it together and then shove it in there. Okay. Okay. So what we will need to do is a tiny little file here and file this down a little bit. Now that it's all nice and greasy here. So now I have to rinse this off again because I don't want dust from this filing installed in there. I think that's fine. Okay, so it wasn't the greatest idea that I ever had. Let's see. We might need a little bit more grease in my little container here. We're going to put a little bit more on everything here. Again, metal exposed in here as well. Okay, and now we're going to stick that in here like that, right? Put a little bit more on here because now it's all on my hands. Yikes. And not get it all on those numbers up there. My buildup is still in the way. Dang it. Nope, it's not. It's all good. So my little repair buildup stuff is not in the way, but we're not quite on there yet. See that little shoulder here? That plastic needs to slide on that shoulder. I'm pretty sure. Let's not do that. Let's put it back in here. No, isn't that great? No, it's not fitting. Okay, I'm going to take this off one more time because there is something going on here. It's my plastic buildup, I'm pretty sure. So oh yeah. So now you can see that plastic thing here actually goes on that shoulder. And that's what we were trying to achieve. And now we just have to push this warm drive gear against this metal gear so they line up. And the part that I'm not 100% sure about is where the numbers need to be. But I think we're good. Yeah, I think that we're good. There, snap. So all the gears lined up, the plastic piece all the way on, and now we just need to grab a little screw here. They don't have Loctite on those screws, but they do have paint on them. The yellow paint that you see, that is there to keep them in place from rattling loose without putting anything on the threads. And okay, I'm not going to tighten it up too much because that's probably why this cracked in the first place. I'm not 100% sure if we will do the same. Maybe we should. Maybe we use a paint marker and just put a dab of paint on it. Let's see if we can accomplish that. That's black. Black would work. Right? Here's black paint. Kind of like that. Just soaks in, dries up, and gives a little bit resistance to loosening. Here on this part, it's going to be difficult because there's grease and whatnot, but let's do it anyways. Yeah. I don't know if they use, maybe there is paint that aircraft mechanics use called pinstripe, or no, torque striping is what it's called. Torque striping. It's a paint that's really thick and kind of sticks on there really well. So without touching the black paint, I'm going to try to reunite those two pieces here. So we're going to put some grease on this final thing down there. The other one was already greased up. The little bearing here at the bottom is also greased up. Let me make sure we have it all focused for you guys. There we go. Let's put some smear here in the entire thing. I should probably go with the direction that the thing usually spins. And make sure you have grease in every groove. And, which direction? This way. See that pin here? That needs to go into that there. Hello. What's the story? Oh yeah, there's also a pin, and there's a pin, and they need to line up with those holes down there at the bottom. So wiggle, wiggle, wiggle. What's the story? What's the holdback? Here we go. Yikes. Doesn't slide together all that easily here. Or is that already it? Oh, I guess that's it. Yep, that's all the way in. So now we're going to try to put this on here without dropping anything. And if you guys remember, there was that flathead screw going there, and there was another one. Maybe this one here. Yep. And there. Click. Don't overdo it. It's plastic to metal. And then we're going to check this little puppy here one more time. Okay, that's good. And then these three here maybe. Now that they are still tied. Okay. So I think we have the internals all figured out. You can see the little, I don't know if you guys can see it, the little brass piece wiggling just like the needle would. So we have it more or less together. Now we just have to put the dial and the hand back on, but I am still kind of contemplating. If you look at the needle, how crusty this thing looks, I'm afraid, I think this is metal. It's not plastic. I think I want to repaint those. And I also want to use a little bit of some water and some Q-tips and clean the dial off, which is still sitting over there here in our little container. So why don't we go and I wash my hands, get the hand. You know what? I think I'm going to do this instrument first. Take it apart, do the same lubrication. The drive should be fairly similar. I can see there is the same kind of gearing down in there. So everything should be fairly similar. And just clean it all out just like the other one. And then we're going to clean up the dial and repaint the hand. And in the meantime, I'm going to park this here somewhere out of the way. So internally, it's done. Externally, it needs some more love. Okay. I'll be right back. So I think we're going to cut this video off here with our speedometer more or less reassembled except the dial and the hand, which will be the last thing that we're going to do. If you now find part 2 of this whole thing, we're going to work on the tachometer. We're going to do the same thing, take the hand off, make sure we don't mix them, and do the whole cleanup inside, internally, figure out how to take it all apart. And this is going to be part 2. All right, guys, thanks for watching.